I'm Dave Lavery. I work at NASA headquarters in Washington, D.C. My formal title is Program Executive for Solar System Exploration. What that really means is I'm the person at NASA headquarters who has full-time responsibility for several of Mars exploration missions, and primarily from the technical and the engineering side. I'm basically doing the job that I've wanted to do since I was 6 years old. Growing up in the 60s in the Apollo era, all of my heroes were Neil Armstrong, Chuck Yeager, John Glenn, and those are the guys that I wanted to be, and really have been on that path ever since I was about 6, and basically said if I can't, found out when I was in high school that because my eyes are sort of weird that I could never actually fly myself as an astronaut, but I figured if I couldn't be an astronaut, then what I'd want to do is work on the machines that could go into space sort of as my proxy if I couldn't go there myself. So that's how I got into robotics and artificial intelligence, and then working from that, basically followed that through to the point of working on projects that send robots to planets to explore and let them be my proxies. Got very interested in doing computer programming and computer system design while I was in high school. Actually had my first job as a computer programmer at age of 15, and sort of followed that through into a degree in computer science from Virginia Tech, and then graduate school doing work in artificial intelligence, and that's sort of what led into the robotics interest. The real thing that I learned about design early on and that started to get me excited about is recognizing even within something like software, and in fact a virtual product, there's an enormous amount of design work that goes on right up front. And it actually becomes one of the more interesting parts of the problem when you start looking at software design. And then from that you start to see parallels between a virtual product design work and process into one that's hardware oriented. I think one of the biggest things is just get fully engaged with the students as early and as often as you possibly can. Show them what a design problem can be like. Let them understand that something even as simple as building a model out of Legos. If you really think about it, you go through a design process. You try to figure out, what am I going to build? Even if it's a process of just sticking bricks together to sort of see what evolves, you still go through the process of thinking about what do I want it to be, what do I want it to look like, how am I going to make this, and then as I build it, as I create it, do I need to change, do I need to update my expectations and move some bricks around and change that? And if you look at the process of just building something from Legos as a design problem, you see how complete of the design process gets wrapped up in that. And again, the same way that I learned to translate my design process knowledge from software to hardware as I went through my career, students will do the same thing. They'll take that early understanding of how to design with something like a Lego block and translate that into successively harder and more complex problems. If you really are interested in it, if you really want to dream about it, and you really want to do it, you can. I'm a perfect case to say, start when you're 6 with something that excites you, stick with it, and you'll end up doing it for your entire career and you'll love it.